is a function f of x. F of x is 4 minus 3x minus x squared. Can anybody right away tell me what type of curve am I going to sketch? Anybody tell me? Yeah?
N-shaped.
It's going to be n-shaped. And Owen, how did you identify that this is going to be n-shaped?
It's minus x squared.
Minus x squared, that's perfect. Okay. Now, the next thing is draw the graph f of x in the domain minus 5 less than x less than or equal to 2. Now, see this business here? You don't actually have to do that in a test. You used to have to do it, it's an old question. These days you just have to be able to input it into the calculator. So anytime you see a table, you don't have to do the table out if you don't want to. The table itself is just doing it all individually, like replacing x with minus 5, figuring out what the answer is, replacing x with minus 4, figuring out what the answer is. So look, I can do one of them for you if you want, just to make it clear what exactly it does. What it does is, you basically replace, if I want to do minus 4, it's minus 4 minus 3 times minus 4, and then minus 4 squared, and then you're going to get 4 plus 12, that's going to be 16 minus 16, and that's going to equal 0. So my first 2 points are minus 5 minus 6 and minus 4 0. But as I specified, in most recent junior cert you no longer have to do that. All you guys need to be able to do is find your calculator.
Sir?
Yeah.
No, close.
No, because it's a plus 16 within the bracket, and then it's a minus on the outside, making it minus 16. So like this. Oh, sorry. So what you do there is you can put that into the calculator and find out what exactly it is here. So modes, then you just say minus 4 squared, and you see that's minus 16. That's predicted. Now, what is the function this time around? The function is 4 minus 3x minus x squared. And where does it want me to go from? Minus 5 all the way to 2. So starts at minus 5, ends at 2, step of 1, long behold.
How do you know the step changes?
Well, you can see from the graph that the step is 1. Step is usually always 1. The only time, can anybody in the class tell me the only time I'll use a step of 0.5 for instance? Yes, Sean?
I want to make sure the curve.
When I'm drawing the tip of the curve and I want to make sure that my turn is correct. Okay? Now guys, look at this. Do these points match up to the 2 I calculated manually?
Yeah.
Minus 5, minus 6, minus 4, 0. The next one? Minus 3, 4. The one after that? Minus 2, 6. Minus 1, 6. And then after that? 0, 4. And then after that? 1, 0. And 2 minus 6. Does anybody see a pattern in the y values? Does anybody see a pattern in the y values? Minus 6, 0, 4, 6, 6, 4, 0, minus 6. Do you see it?
Yeah.
Minus 6 and minus 6. 0, 0, 4, 4, 6, 6. And the peak is going to be located between the two sixes. Okay. Now, what it wants me to do is wants me to draw this graph. So before I do anything else, I'm going to go about drawing this graph. Okay. So to draw this graph, what I'm looking at here is oh, that's not it. 1 second, guys. There we are. So, need to start drawing this graph. So, what I'm going to do first and foremost is what's my maximum value of y? What's my maximum y value? Anybody know? My maximum y value is 6. What's my minimum y value? So 12 blocks would work nicely, wouldn't it? So 12 blocks. So what we're looking at here is we're just going to set it up. Now, I'm going to set it up slightly to the left. Why am I setting it up slightly to the left? Because slightly to the right. Anybody know?
Not that many positive x values.
Not that many positive x values. Couldn't have said it better myself, Rory. Now, there you go there. You've had your graph drawn here now. What I'm going to do next is I'm just going to go up in twos, okay? Oh, not with that heavy of a marker on that. So, we're going to go 2, 4, 6, minus 2, minus 4, minus 6. And then we're going to go across. I'm going to go across in twos as well. Okay? So I'm just going to call that. I want to spread out the graph a bit. So I'm gonna make it wider than I would normally. Minus 2, minus 3, minus 4, minus 5. This is going to be 1 and 2. Is that graph okay?
Yeah.
It is, because the x-axis is all the same and the y-axis is all the same. The x and y-axis don't have to be identical, regards to their scaling. So the scale on the x-axis, the scale on the y-axis is normal. One block is worth 1 unit, while the scale on the y-axis is normal, while the scale on the x-axis is 2 blocks for 1. That's okay. You're allowed to do that, but it does have to be the same on the same axis. Sean?
Does the x-axis only have to go by 1?
No. Whatever I choose. Yes.
You know, you said the step is 1 for this one.
Yeah.
Then why is the kind of potatoes on the...
It isn't. It isn't. I just didn't draw them all out.
Okay.
Alright?
Yeah.
Yes, James.
So is it do you have it in like every two blocks every 2 blocks you do by 2 there, but that's 2. So is it like you can have 1, 3, 5, 1, 3 and 5, but you can't have 1?
No, it has to go up. You can't have 1, 3, 5 because the 0 to 1 has to be the same gap as 1 to 2.
So you can have 2, 4, 6, but you can't have 2.
Or 3, 6, 0, 3, 6, 9, 12. Yeah, you can do 3 blocks or 4 blocks, but
Or like infinite blocks.
you couldn't do this though, James. You couldn't say, look, that's number 1, and then say 2 blocks later, that's number 2. You're not allowed to do that. Okay. So guys, what happens is when you're scaling it, okay, what happens is if I scale it, that's a graph, okay? If I make the x-axis wider, all it does is it changes the shape, but it's still the same graph. It's like a zoom function. You're zooming in on part of it. It's still the same shape, but you're just having a different look at it. Okay? It's like your face in the mirror. If you're to elongate your face, it's still your face. It's still symmetrical, but it's just elongated. So that's what I want you to think of. That's what I want you to think of scaling. Okay. Now, what happens here, guys? We've got to draw this. Okay. So what's my points? -5, -6. N shape as. Oh dear. N shape as thought. -4, 0. -3, 4. -2, 6. -1, 6. 0, 4. Sorry? 1, 0, and 2 minus 6. Now guys, if you guys aren't sure about how far to go up, what I suggest you do, see the way I'm sort of trying to guess, where do I stop in the middle of the two of them? Because I definitely don't go straight across. I have to do like a loop. Do we understand that? So what I have to figure out is how do I figure out how far do I go on my loop? So what I suggest we do is we just go back to our work that's already been done. We want to figure out where 1.5 is. So we just go back to the start, equals. Now we put a step of 0.5 in, and we go to -1.5. Oh, sorry, -1.5. There it is, 6.25. 6.25 into the air. So it'd be just around, just there. Very small actually. Oh wait a second. 6, 7, 7 is here, so it'd be very smooth. So 1, and then over, then there we go. Happy enough with that?
Yeah.
Now guys, we need to answer some questions now. What are the questions we're being asked? I'll obviously have to, unfortunately for me, I have to drag this down now. So, what's the first question?
The time, temperature, size.
Sorry?
time when the temperature was highest?
The time the temperature is temperature 11 a.m. So when does it start? 6 a.m. is x equals minus 5. So this here, it says it here. This is 6 a.m. So where's 12 a.m., 11 a.m.? 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m. What's the temperature at 11 a.m.? 4 degrees. Now, the time when the temperature was highest? Down here, isn't it? 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock. In between 9 and 10 o'clock? Half 9. The times when the temperature was 3 degrees. 3 degrees? It's located here, isn't it? So 3 degrees across and down. I'm going to the 3 degrees is the y-axis. Yeah? So temperature is the y-axis. And where does 3 o'clock hit? Hits in between 7 and 8. So it's just after 7:30. Call it 7:35, 7:40. Somewhere there. 7:35 I suppose. Okay, let's try 7:35. And what about the other one?
11.
That's 9, 10, 11. Halfway between half 11 and 11. Just call it 20 past. Or 11:15. The number of hours the temperature was above freezing point. What's above freezing point mean, lads? Above freezing point. Above 0. Where's it above 0? See where I'm shading in here? That's all above 0. How many hours does that happen for? 7, 8, 9, 10, 11, 12. How many gaps? That's 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. 5 hours. Is that okay?
Yeah.
Alright.
It's not below 0.
What?
It's not below 0. Minus.
Yeah, minus 6.
No, above 0. It's the y-axis, not the x-axis.
Yeah, but it's still like minus 4. Oh, no, sorry.
No, it's not. Minus 4 is on the mark. It's where the line is. Minus 4 is time, not temperature. The temperature is 0 on this point here. It's the y-axis. It's the y value. Okay? Alright guys, now, moving on. We have question 5, okay? So, question 5. Draw the graph of the function. Will somebody put that into your calculator please and tell me what points we get out? Graph the function from 0 to 6. 0 to 6. So you put in your function here. And we're going to say f of x equals 6x 6x minus x squared. There it is there. And then we're going to say 0 to 6. And step of 1. And what points do we get? 0, 0. 1, 5. 2, 8. What's after 2, 8? So Higgins said 3, 9. Yeah, after that Higgins? 4, 8. After that? 5, 5. And after that? 6, 0. Okay, close. Now, you now have to design your graph. It says draw the graph. It's the very first part says draw the graph. Okay? So once we decide that we have to draw the graph, got to do next is got to pick an x and y axis. Where should the y axis be located? It should be a bit more to the left. Why is that, Rory?
Because there's less, a bit more to the left side because there's more positive than negative.
Yeah, it's just 0 to 6.
Yeah.
Now guys, this time 0 to 6, okay, so what we're looking at here is we can see how many blocks we have to use. So we have to go all the way up to 9. How many blocks would I need to do a 1 to 2 scale? sorry, 2 blocks were 1. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that better?
Yeah.
It is 9, isn't it? 9 is the maximum value. So that's a good thing to do that. The bigger you can make your diagram, the more accurate it becomes. Now, how big could I make this scale here? Could I do 3 blocks or 2 blocks? I could do 3 blocks. Let's say I get away with 3 blocks. 1, 2, 3, 4, 5, 6. What does the y-axis represent in this question? Anybody know what the y-axis represents? Anybody know?
Height in meters.
Sorry?
Height in meters.
The height of what?
Height in meters.
Height in meters? Yeah. And what does the x-axis represent? Nobody knows. So, if you reread the question, so we're going to have here is that the height, the x is in seconds, okay? So each unit of the x-axis represents a second. So our first question is find the greatest height reached by the golf ball. The greatest height reached by the golf ball, okay? So what we're going to do here is going to draw this out. 0, 0. Oh, there's a mistake now there, isn't there? Because this here has to be a gap of 2. Oh, I see it now. I have to shift this. Sorry, excuse me. That has to be 1 down, doesn't it? Now it's working again. Okay, because the first gap wasn't 2. Now, let's begin. 0, 0. Here. 1, 5. Here. 2, 8. 2, 8. There. 3, 9. There. 4, 8. Here. 5, 5. There. And 6, 0. Here. Draw your graph. There you go. Your graph there. What's the first question say? What's the greatest height reached by the golf ball? Can anybody tell me? Greatest height reached by the golf ball? 9 meters, because the height here goes across to 9 meters. So answer the part 1, 9 meters. Now, what's the question for question 2? The height of the golf ball after 1.5 seconds. Where is the height equal to 1? Where is the time equals 1.5 seconds? X equals 1.5. Where's 1.5? Halfway up, isn't it? Now draw a line going all the way up. You should use a ruler. I haven't got a ruler available to me. And then go straight across. And what do we think the answer is going to be? 6.6, 6.7. Okay, so let's call it height equals 6.7 meters. Anybody else? What's the next question after that? Anybody? After how many seconds was the ball 10 meters above ground? 10 meters above ground. Does that even happen?
No.
0.
I don't think this time exists because the maximum height is 9 meters. Let's check it out again. Let's go to the calculator. It's 6x minus 6 squared, isn't it? 8x squared.
Sure, we'll check the back and forth.
6x minus x squared. No, it should be alright. Start 0, 6, step of 1. This time doesn't exist as the maximum height is 9 meters. Okay, kind of back ourselves with that. It doesn't reach 9.
So in back in the book it says after 0.4 seconds and 5.6 seconds.
0 point?
After 0.4 seconds and 5.6 seconds.
Well, I'm going to disagree. I don't think that. Did you say after 0.4?
Yep.
Now 0.4 is around here. So I reckon they're talking about different heights and 5.6, that's a faulty question, guys. Doesn't work. Higgins.
Would they not be in tens or maybe if that's the thousand?
Are the height in tens?
Yeah.
Oh, sorry, guys. There it is. There. Sorry, excuse me. We left out a vital piece of information there. Actually, sorry, excuse me. We've been actually leaving out a vital piece of information. Believe it or not. Look at this. Sorry, guys. Each unit on the y-axis is worth 5 meters. So let's go back to the start again. What's the greatest height reached by the golf ball? 9 blocks. But what does 9 blocks actually represent? 45 meters. And that's very important. What about part 2? The height of the golf ball after 1.5 seconds? We said it was roughly 6.7, didn't we?
Yeah.
6.7 blocks multiplied by 5? 33.5 meters. What about part 3? When was it 10 meters above ground? 10 meters equals how many blocks?
2.
2. Go across from 2 blocks. And where it hits the line, I'm going to say roughly 5.6 seconds and 0.4. Is that roughly right?
Yeah.
0.4 and 5.6. Because it says each one is worth 5 meters. And after how many seconds did the ball reach its maximum height? Anybody?
3.
3. Okay, guys. So a bit of delay there.